Very quickly, we figured out he's dead, and it turned into a bit of this is a crime scene to some degree. CSI crime scene wildlife.
For years, the story of the Everglades was simple and grim. An invasive species had arrived, and nothing native could stop it. Burmese pythons, some longer than a pickup truck, had spread through South Florida's wetlands with no natural enemy in sight. Wildlife agencies spent millions trying to slow them down. Scientists tracked them, hunted them, studied them, and mostly just watched the numbers get worse. Then, in the middle of a routine tracking study, something started killing the pythons themselves, and for months, nobody could explain what it was. This is the story of how that mystery was solved, and what the answer revealed about a swamp that everyone thought they already understood. In the early 2020s, biologists working in the wetlands of southwest Florida set out to do something that sounds almost boring on paper: track juvenile Burmese pythons using small surgical implants, then follow their movements over months to understand how the snakes spread, where they nested, and how far they traveled as they grew. It was patient, unglamorous fieldwork. Researchers waded through flooded cypress stands and sawgrass prairies carrying antennas, logging coordinates, checking signals, building a data set one data point at a time. Nobody expected the study to turn into a murder mystery, but that's essentially what happened. Not long after the pythons were released back into the wild with their trackers implanted, a strange pattern began to show up in the data. The snake's signal would move steadily for days or weeks, feeding, resting, relocating, and then simply stop. Not slow down. Not fade out gradually the way a transmitter does when its battery dies. Stop completely all at once, and then stay in exactly the same spot indefinitely. At first, the team assumed equipment failure. Transmitters do fail. Batteries corrode, antennas snap, moisture gets where it shouldn't. But when researchers went out to recover the dead units, what they found didn't look anything like a malfunction. The first recovery site set the tone for everything that followed. The team hiked, waded, and pushed through dense vegetation to reach the last known coordinates of a python that had gone silent after weeks of normal movement. They expected to find a transmitter lying in the mud next to a decomposing snake, or maybe evidence of a predator's kill: torn skin, scattered scales, something. Instead, they found nothing on the surface at all. No body, no blood, no drag marks through the grass, no shed skin curled in the leaf litter. Just a faint, steady beep coming from somewhere close by, but with no obvious source. It took some searching before the team realized what was happening. The signal wasn't coming from the ground. It was coming from inside something. This wasn't a one-time fluke. Over the following months, the same scenario played out again. Signals would go quiet. Researchers would trek out to the coordinates, and instead of a corpse, they would find an unmistakable transmitter pulse radiating from inside a living animal's body. Whatever was killing these pythons wasn't just killing them. It was swallowing them, implant and all, leaving no physical evidence behind for the searchers to examine. When the team eventually recovered enough of these mystery predators, or at least got close enough to X-ray one, the images confirmed just how strange this was. On the film, researchers could clearly see the curled outline of a python's spine, fully intact, sitting inside the digestive tract of another animal. There was no sign that the python had been torn apart or chewed into pieces first. It had gone down as a single, whole meal. For a team of scientists who had spent years documenting how Burmese pythons devastate Florida's native wildlife, watching an X-ray of a python being eaten, rather than eating, was almost impossible to process. One of the lead researchers would later describe it as one of the strangest moments of his career, a discovery that appended the working assumption that nothing in the Everglades could compete with these snakes. To understand why this discovery mattered so much, you have to understand just how one-sided the python invasion had been up to that point. Burmese pythons are native to the humid forests, marshes, and floodplains of Southeast Asia, countries like Myanmar, Thailand, and parts of Indonesia. In their home range, they exist within a food web that has had millions of years to adjust to them. There are predators large enough to threaten young pythons, competitors for the same prey, and disease and parasite pressures that keep their numbers in check. None of that ecological context traveled with them when they arrived in the United States. The pet trade is largely responsible for how they got here. Throughout the 1980s and 1990s, baby Burmese pythons were sold cheaply as exotic pets, marketed as low maintenance and visually striking. The problem is that they don't stay small. A python bought as an adorable 2-foot hatchling can grow into a 16-foot, 90-pound animal within a few years, an animal most households are simply not equipped to keep. As owners realized what they'd taken on, many released their snakes into canals, retention ponds, and the edges of the Everglades rather than caring for them or surrendering them properly. Then, in 1992, Hurricane Andrew tore through South Florida and destroyed several reptile breeding and import facilities in the region. An unknown number of pythons, likely in the hundreds, escaped directly into the wild in the chaos that followed. What had been a slow trickle of released pets turned into a much larger founding population, scattered across an ecosystem that had no idea what to do with them. And that ecosystem paid for it. Long-term surveys conducted by U.S. Geological Survey researchers and university ecologists found catastrophic declines in mammal populations across areas where pythons had become established, raccoon and opossum sightings dropping by more than 90% in some survey routes, bobcat observations falling sharply as well, and marsh rabbits and cottontails nearly vanishing from large stretches of habitat they had occupied for generations. Full-grown white-tailed deer have been found inside python stomachs. So have alligators. Researchers examining python gut contents over the years have documented dozens of different bird species among their prey, including migratory birds that fly enormous distances to winter in Florida's wetlands, only to never leave. State and federal agencies threw a wide range of tools at the problem. Import bans, bounty and incentive programs, train detection dogs, thermal imaging drones, environmental DNA sampling to detect python presence in water, and large public removal competitions that draw hunters from across the country. All of it helped remove individual snakes, thousands of them, over time, but none of it meaningfully slowed the spread. Estimates of the total wild population in Florida run from the tens of thousands into the hundreds of thousands, and most experts agree that removal efforts, however well organized, are only scratching the surface. For years, the honest assessment from people who study this invasion closely was blunt. Nothing in the Everglades was positioned to push back. That was the backdrop against which Dr. Bartaswick's research team was working when their python signals started going dark. It's also why the explanation, once they found it, felt so unexpected. Before they had any video evidence, the team tried to reason their way to an answer using the only asymmetries in the data. An alligator was the obvious first guess, the Everglades' most famous apex predator, more than capable of overpowering even a large python. But alligator kills tend to leave a signature: crushing bite marks, torn tissue from death rolls, partially consumed carcasses left behind because alligators often can't finish enormous prey in one sitting. None of the recovery sites showed anything like that. There was no physical trauma at all, no carcass fragments, nothing dragged or stashed nearby. A Florida panther was the next candidate. Panthers are ambush predators capable of killing prey many times their own size, and they typically deliver a killing bite to the skull or spinal column, often leaving claw marks and drag trails as they move a kill to cover. Again, the evidence simply wasn't there. No fur, no scratch marks, no compressed vegetation suggesting a large cat had hauled a carcass through the area. Black bears were considered and dismissed for a more basic reason. Even an opportunistic bear willing to scavenge a python carcass is not built to swallow a 13-foot snake whole and leave zero trace behind. The math didn't work. One by one, the team crossed off every predator with an established reputation in the Everglades food chain: hawks and owls capable of taking very young snakes, but not animals of this size. Other large constrictors, which don't typically prey on pythons. Anything in the raptor or mammalian carnivore guild that might plausibly account for a python vanishing without a mark. Nothing fit the evidence. Whatever was responsible was killing something enormous, swallowing it entirely, and leaving no external sign of struggle whatsoever. With no clean answer emerging from process of elimination, the researchers did the only thing left to try. They set up trail cameras aimed at the last known locations of the missing pythons and waited for the swamp to show them what they were missing. Weeks of footage came back mostly uneventful. Wind moving through the grass, wading birds, the occasional raccoon passing through frame. Then one clip stopped the review session cold. The footage showed a thick-bodied, dark snake lying motionless at the water's edge, blended almost seamlessly into the surrounding decayed vegetation. It wasn't dramatic. It wasn't even easy to spot at first. And then, in an instant, it struck, a fast, precise attack on a much smaller python that had wandered too close. What followed was slow and methodical. The predator worked its jaw around the python's body and began the long process of swallowing its prey whole, starting from the tail and working forward in stages, a process that can take a considerable amount of time for prey this size. The animal on camera was a cottonmouth, a venomous pit viper that has lived in Florida's wetlands for thousands of years, and an animal that most of the researchers on the team and most people who spend time in these swamps generally had walked past without a second thought more times than they could count. A snake that everyone associated primarily with defensive encounters, the classic open-mouth threat display that gives the species its name, turned out to be quietly and repeatedly preying on one of the most feared invasive predators in North America. Subsequent X-rays of recovered specimens confirmed just how extreme these predation events could be. In one especially striking case, a cottonmouth measuring under 4 feet long had consumed a python nearly its own body length, an act that pushes close to the physical limits of what researchers generally believe possible for a snake of that size. It wasn't a fluke either. The tracking study documented multiple instances of pythons killed in a manner consistent with cottonmouth predation over the course of the project. Once researchers knew what to look for, the cottonmouth's capabilities made a lot more sense, because on paper, this snake has always been a far more capable ambush predator than its reputation suggests. Cottonmouths, scientifically classified as Agkistrodon piscivorus, are heavy-bodied pit vipers built for semi-aquatic environments, flooded forests, marshes, slow-moving creeks, exactly the kind of habitat where Burmese pythons have thrived. Adults typically range from about 2.5 to 4 feet, with larger individuals occasionally documented beyond that. They are not built for speed across open ground. They are built to wait motionless, in exactly the kind of tangled, waterlogged cover where a python might also be lying still. Like all pit vipers, cottonmouths have heat-sensing organs located between their eyes and nostrils, capable of detecting subtle infrared differences in their environment. This means they aren't hunting primarily by sight or scent. They're detecting warmth. A python that has recently basked or is digesting a meal and running slightly warmer than its surroundings can stand out clearly to a cottonmouth, even in total darkness or dense cover. Camouflage that would fool a human observer, or even most other predators, doesn't do much to hide a heat signature. Then there's the venom itself. Cottonmouth venom is primarily hemotoxic, meaning it targets blood cells and tissue rather than the nervous system, causing localized tissue damage and disrupting normal blood clotting. For smaller or juvenile prey animals, envenomation is frequently fatal, and death can occur relatively quickly once the toxin spreads through the bloodstream. Cottonmouths facing prey that could fight back typically use a strike-and-retreat strategy, deliver one accurate bite, withdraw to a safe distance, and wait for the venom to do the work before returning to feed. Importantly, this isn't a new behavior triggered by the python invasion. Cottonmouths are known to be highly opportunistic and, notably, ophiophagus, snake eaters, with documented diets that include a wide range of other snake species, including other cottonmouths. Preying on smaller or juvenile snakes has always been part of their ecological role. Burmese pythons simply represent a new item added to a menu that was already broad. Juvenile pythons, in particular, haven't yet developed the size, strength, or crushing power of adults, which makes them a genuinely vulnerable target for an ambush predator equipped with thermal detection and a fast-acting venom. Perhaps the most important thing this study revealed wasn't just that cottonmouths could kill pythons. It was that they weren't the only native species doing it. Careful review of the tracking data showed that a significant portion of monitored pythons, 5 out of 19 in one phase of the study, had actually been killed by American alligators, including at least one alligator estimated at only around 9 feet long, smaller than many of the pythons it had successfully preyed on. Alligators, it turned out, hadn't simply been losing ground to the invasion this entire time. They had been fighting back too, it just hadn't shown up clearly in earlier survey methods. Then, in the summer of that same research period, trail cameras captured something even more unusual, a bobcat directly attacking an active python nest. This wasn't scavenging abandoned eggs. Footage showed the bobcat engaging the nesting female directly, driving her back with repeated swipes, and then methodically raiding the clutch. It appeared to be the first documented case of a native North American mammal actively raiding a Burmese python nest, evidence that at least some native predators may be developing new, targeted hunting behaviors in direct response to a threat that didn't exist in their environment a generation earlier. Other cameras and tracking data pointed to still more predation events, raptors picking off very young pythons in exposed positions before they could grow large enough to become a serious threat, and scattered but real documentation of black bears and Florida panthers separately preying on pythons across the study area. Put together, the picture that emerged wasn't one lone predator holding back an invasion. It was a loose, uncoordinated coalition: pit vipers in the undergrowth, alligators in the water, bobcats at the nest, raptors from above. all independently exploiting the same vulnerability in the python population without any of them being aware the others were doing it too. As encouraging as this discovery was, researchers have been careful not to overstate it. The math of the python invasion remains brutal. A single female Burmese python can lay anywhere from a dozen to more than 3 dozen eggs in one clutch, and she'll coil around them for the entire incubation period, generating heat through muscle contractions and defending the nest aggressively against anything that gets close. Pythons mature quickly and can live for well over a decade in the wild, giving each individual snake many opportunities to reproduce. Human-led removal efforts have made a dent. Thousands of pythons have been taken out of the wild through licensed hunting programs and organized public removal competitions, some of which draw participants from across the country and remove hundreds of snakes in a single weekend event. But even the researchers running these programs are candid that removal, on its own, is unlikely to ever eliminate the population. Pythons are extraordinarily good at staying hidden. They can lie motionless within a few feet of an experienced observer and go completely undetected. Much of their prime habitat in the Everglades is difficult or impossible to search systematically on foot, by boat, or even by drone. That's what makes the native predator response so significant, even if it's not a complete solution on its own. Every cottonmouth strike, every alligator kill, every bobcat raid on a nest represents a small but real check on population growth, and more importantly, a behavior that can potentially be passed down and reinforced across generations of predators living in python territory. Researchers don't yet know how much of this predation pressure is instinctive opportunism versus a genuinely learned, spreading behavior. That's part of what ongoing studies are trying to determine. What they do know is that the narrative of a completely unopposed invasion was, at minimum, incomplete. The Everglades were never as defenseless as the data initially suggested. The predators were there all along, underestimated, understudied, and quietly adapting to a threat nobody had prepared them for, entirely on their own terms. The tracking study that uncovered all of this is ongoing. Researchers continue to expand their transmitter network, hoping to build a large enough data set to answer the question that actually matters, not whether native predators can kill individual pythons, that's now well documented, but whether that predation pressure, combined with human removal efforts, environmental limits, and disease, can meaningfully slow the python population's overall growth over the coming decades. Nobody studying this invasion is claiming the fight is close to over. The python population in Florida remains enormous, and the ecological damage already done to native mammal populations will take a very long time to reverse, if it reverses at all. But the discovery that cottonmouths, alligators, bobcats, and other native animals have been quietly pushing back the entire time, often in ways sophisticated enough to leave zero physical evidence behind for human observers, has genuinely changed how researchers think about the Everglades' capacity to defend itself. Somewhere in those wetlands tonight, a cottonmouth is very possibly digesting a meal far larger than anything textbooks would have predicted it could handle. And not far away, another python nest may be hatching, restarting the same cycle that's been playing out for years. The outcome of that ongoing contest is still unwritten. But for the first time in a long time, it's no longer a story about a swamp with no defenses left. It's a story about an ecosystem that never stopped fighting. It just took the right camera, in the right place, at the right moment, for anyone to notice. There's a broader lesson buried in this story, one that reaches well past the borders of the Everglades. For decades, invasive species research has tended to focus heavily on the invader, how it spreads, how fast it reproduces, how much damage it does, and what humans can do to remove it. Native predator responses have historically gotten far less attention, partly because they're genuinely hard to observe. Predation events in dense wetland habitat often leave little or no trace, especially when the predator swallows prey whole rather than leaving a carcass behind. Without a transmitter accidentally revealing the location of a kill, and without cameras positioned in exactly the right spot at exactly the right time, this entire pattern could have remained invisible indefinitely. That has real implications for how researchers study biological invasions elsewhere. If cottonmouths were quietly preying on pythons for years without anyone noticing, it raises an obvious question. What other native versus invasive interactions are happening right now, undetected, simply because nobody has set up the right monitoring system to catch them? Ecologists working on other invasive species problems, lionfish in Atlantic reef systems, feral hogs across the American South, various invasive fish and amphibian species elsewhere in the country, have started paying closer attention to exactly this kind of overlooked native resistance, rather than assuming an ecosystem is simply defenseless just because the obvious. Easily observed predators aren't the ones doing the work. It also complicates the sometimes tidy narrative around invasive species management. It's tempting to think of an invasion as a straightforward battle between an unstoppable newcomer and a passive, overwhelmed native ecosystem, with humans as the only possible intervention. What the cottonmouth footage suggests instead is something messier and in some ways more hopeful. Ecosystems are not static. Individual species within them can and do respond to new pressures in real time, sometimes through existing behaviors applied to a new target, and sometimes, as with a bobcat filmed raiding a python nest, through what may be genuinely novel behavior nobody had documented before. None of this is an argument for stepping back and letting nature sort itself out. The scale of the python problem in Florida is still far beyond what native predators alone are likely to solve, and the researchers who uncovered this pattern have been consistently clear about that point. Removal programs, detection technology, and policy efforts to prevent future invasive releases all remain essential. But understanding that native wildlife isn't purely a passive victim in this story changes how conservation efforts might be prioritized going forward. Protecting and supporting healthy populations of cottonmouths, alligators, and mid-sized native mammals like bobcats may turn out to be a meaningful part of managing the python population over the long term, rather than an afterthought to human-led removal. Back in the field, the research continues in a way that looks almost identical to how it started. Researchers wading through the same flooded cypress stands, checking the same kind of signals, logging the same kind of coordinates. What's changed is what they're watching for. A silent transmitter used to be treated as a data gap, a lost data point to note and move past. Now it's treated as a lead. Every time a signal goes still, the team has a new set of questions to ask. Which predator was responsible this time? Was it a repeat location, suggesting a den or ambush site being reused? Does the timing line up with known feeding or nesting patterns for cottonmouths or alligators in that specific stretch of wetland? Expanding the transmitter network is a slow, expensive process, and building a large enough dataset to answer questions about population-level impact, rather than just documenting individual predation events, could take years. But every additional data point adds resolution to a picture that, until recently, nobody knew was even there to be drawn. The Everglades has always been a difficult place to study closely. Dense vegetation, standing water, and extreme heat make even simple tracking work physically demanding. That's part of why this pattern went unnoticed for as long as it did. What started as a straightforward tracking study meant to map how pythons move and nest ended up documenting something nobody had set out to find: a native ecosystem quietly pushing back against one of the most damaging invasive species events in North American history, using methods too subtle for standard survey techniques to catch. The story of the Everglades python invasion isn't over, and it likely won't have a clean, decisive ending anytime soon. But it's no longer accurate to describe it as a one-sided fight. The swamp has been defending itself the entire time. It just took a very patient research team, a lot of silent transmitters, and one unforgettable piece of camera footage to prove it.